I had this moment last Tuesday that I think just it, it perfectly captures the love-hate thing we all have with AI right now.
Oh, yeah.
I was deep into this project, a really complex coding script. I'd spent, I don't know, maybe an hour feeding this chatbot context, explaining libraries, setting up variables. We were in the flow. It felt like I had this brilliant partner.
That flow state is incredibly seductive, isn't it? You
Hmm.
feel like the machine finally gets you.
Exactly. And then I asked for one simple revision.
Oh,
One. And suddenly, it prints the code in Java.
oh no.
We had been working in Python for 60 minutes, and it forgot the naming convention from minute 5. It was like the bot just hit a wall, amnesia.
Yeah.
And honestly, I was furious. I felt like I was working with some lazy intern who just stopped listening.
That emotional reaction, calling it lazy, feeling like it's ignoring you, that's universal. But the research we're diving into today suggests that that anger is a little misplaced. You aren't dealing with a behavior problem.
Agree.
You're crashing into a wall of physics.
Physics? That sounds a bit dramatic for a chatbot glitch. I just assumed it was a bug, or maybe the server timed out.
It feels like a bug, but it's actually a fundamental constraint of the architecture.
Yeah.
We're looking at the presentation, why long AI chats break down, and its whole point is that we need to stop treating these things like magic and start seeing them as systems.
The architecture of forgetting.
Exactly.
Okay, let's unpack that, because when I'm in that chat window, I'm operating under a very specific assumption.
Which is?
That window is my computer. It's my session. Like if I open a Word doc and type 10 pages, page 1 doesn't just vanish because I typed page 10.
Yeah.
It's saved.
And that right there is the myth of the personal computer.
Yeah.
It's the first mental trap the source material dismantles. When you use your laptop, you have dedicated RAM, a dedicated processor. That silicon is yours.
Right.
But an AI model, it doesn't live on your device at all.
Well, obviously it's in the cloud.
Yeah.
But I assume I have, a dedicated little slice of that cloud, right? A virtual hard drive just for me.
You don't.
Yeah.
And the source uses a much better analogy, the electricity grid.
The grid.
Yeah. When you plug in a toaster, you don't own the generator at the power plant. You're just drawing load from a massive, shared pool of global infrastructure.
Okay, sure. But my toaster doesn't usually stop working because my neighbor turns on their TV.
True, but the grid manages load based on demand. And in the AI world, this shared pool is super dynamic. The resources for your conversation change millisecond by millisecond based on, well, 3 things: task complexity, your payment tier, and crucially global demand.
So when I'm getting those lazy answers or the bot suddenly gets stupid, it might just be because a million other people logged on at the same time.
It's definitely possible. The system has to prioritize. There is no physical memory chip with your name on it. You're just renting a momentary processing state. But that's just the infrastructure side. The real reason your Python code turned into Java, that lies in how the AI reads.
This is the part that always gets me. If it doesn't have a hard drive for my chat, how does it know what I said 10 seconds ago?
Right. This is the concept of the context window. And I think this is where most people's mental model just breaks down. We think the AI has a memory like a human brain that stores facts and pulls them up.
But it doesn't.
It doesn't. It's reconstructing the past. Every single time you type a new prompt, every time the AI has to reread and reprocess your entire conversation history, plus your new message, as one single giant block of text.
Wait, hang on. That sounds incredibly inefficient. You're telling me if I write a novel with an AI and I'm on chapter 10 and I ask it to change one sentence, it has to reread chapters 1 through 9 all over again.
Every single time, from scratch. It's stateless. The only state it has is the text you send it in that exact moment.
That explains why these things are so expensive to run. It's doing the same work over and over again.
It is. And that context window, it's not infinite. It has a fixed capacity. Think of it like a moving walkway, a conveyor belt. It's a first-in, first-out system.
EFO. I remember that from Accounting 101.
It applies here, too. When your conversation gets too long for the window, let's say it's 10,000 words, the system doesn't just stop. It has to make room.
So it drops something.
It drops the oldest tokens, the oldest words, right off the end of the conveyor belt to fit the new ones on.
So my initial instructions, use Python, don't use these libraries, here's the character's backstory. If those were at the very start of the chat,
they fall off the edge of the world. They aren't forgotten in the way we think of it. They literally do not exist in the model's view anymore. To the AI, you never said them.
Okay, that makes sense for the hard limit. If I fill the bucket, water spills out. But here's the thing that bugs me. In my coding example, I hadn't hit the limit. The chat wasn't that long, but it still started getting fuzzy. It still locked the plot. Why does it break down before the window is full?
That is the hidden factor. The source calls it noise. And this is where human psychology really clashes with machine architecture.
How so?
Well, think about how we chat. We drift. The source points to three main culprits: topic drift, repeated phrasing, and side discussions.
Oh, I am so guilty of that. I'll start on the code, then I'll ask about a coffee recipe, complain about the weather, then try to go back to the code.
Right. To you, that's just banter. To the AI, that is signal decay. You're diluting the important instructions with noise. And there's this specific, really fascinating phenomenon called lost in the middle.
Lost in the middle. Sounds like a bad TV drama.
It's actually a statistical reality of transformer models. The data shows that the AI's attention isn't a flat line across the conversation.
No.
It's U-shaped.
U-shaped.
Recall is highest at the very beginning of the prompt, about 95%. And it's highest at the very end, your most recent message, about 92%. But in the middle,
It dips.
it craters. It can drop down to 60% or even lower, depending on the model.
That is wild. So if I bury a crucial instruction in the middle of a long, meandering chat, there's a coin flip chance the AI just glides right past it.
Essentially, yes. It's a quirk of how it understands where words are in a sequence. It pays a lot of attention to the hello and the goodbye, but it can zone out during the meeting.
So this leads to the big question. If we know this happens, and we know it frustrates everyone, why don't they just make the memory bigger? Why are we dealing with these limited windows at all? Just give me a billion words of context.
The why not just add more RAM argument. This is where we hit the hard wall, the quadratic wall.
That sounds ominous.
It is the single biggest bottleneck in AI development. To get it, you have to visualize how an AI thinks. It doesn't just read words in a line. It has to understand the relationship between every single word and every other word.
Okay.
Let's use an analogy. A dinner party. If you have 4 guests and everyone clinks glasses with everyone else, that's 6 clinks. Pretty easy.
Sure.
Now, double the guests to 8. You don't get 12 clinks. You get 28.
To jump.
Now invite 100 people. You're looking at nearly 5,000 interactions. Imagine a context window of 100,000 tokens. It's a combinatorial explosion. The computer is mapping the relationship of every word to every other word every time you hit enter.
So the work doesn't go up in a straight line?
No. It grows quadratically, n squared. If you double the context length, you quadruple the compute cost. Triple it, the cost goes up 9 times.
So if they gave everyone infinite memory...
The latency would be insane. You'd type hello and get a response next week. And the energy bill. It'd be completely unsustainable. We're talking about data centers melting down.
So when I'm getting frustrated that the free tier of a chatbot has a short memory, it's not just the company being cheap.
It's economic physics. Larger context windows require exponentially more compute. That is why the paid tiers exist. They aren't just charging for a feature. They're charging for the massive electricity bill that comes with those billions of extra calculations.
That actually makes sense. But wait, I've seen companies advertising these massive context windows. 1 million tokens, 10 million tokens. How are they doing that if the quadratic wall exists? Are they breaking the laws of physics?
They're bending them. The source talks about some of the architectural workarounds engineers use. They're very clever, but they all come with trade-offs.
Like what? Give me an example.
Okay, one's key caching, key value caching. Remember how we said the AI rereads everything from scratch?
Yeah, the super inefficient part.
KV caching is like a save state in a video game. Instead of recalculating the math for the first 50 messages every time, the system saves the result of that math. So when you send message 51, it just loads the previous state and adds the new bit.
That sounds great. So what's the trade-off?
Because storing all those caches takes up a massive amount of GPU memory. So it solves the compute time problem, but swaps it for a storage capacity problem.
Okay, what about RAGRIG? I hear that acronym everywhere. Retrieval Augmented Generation.
ARG is fascinating because it's basically an admission that the model can't remember everything.
How so?
Think of the context window as memorizing a textbook for a closed book exam. ARGAG changes the rules to an open book test.
Ah, okay.
Instead of forcing the AI to hold your entire company handbook in its active memory, ARGAG searches for the one page relevant to your question, retrieves it, shows it to the model for a second, and says, answer using this.
So it's cheating.
It's efficiency.
Yeah.
But it loses the holistic understanding, right? It might find the specific rule about holiday pay, but miss the nuance in the company culture section because it didn't pull that page. It trades deep synthesis for factual retrieval.
So we have the quadratic wall, we have the U-shaped attention curve, the workarounds are imperfect. It sounds like long-form AI work is Kind of doomed. Are we just supposed to stick to writing haikus?
It feels that way, doesn't it?
Mm.
But the source argues that this defeatism is wrong. The goal isn't to wait for a supercomputer that breaks physics. The goal is to change how we work.
Systems thinking.
Precisely. We have to stop thinking of the AI as a diary or some kind of archivist. The source puts it bluntly. AI is optimized to be brilliant in the moment. It is a conversation engine, not a storage device.
So expecting it to remember a decision I made 3 weeks ago in the same thread is just setting myself up for failure.
Yes, and this leads us right to the master prompt strategy. The source calls it context compression.
Okay, I need this. Because right now my strategy is just to yell at the screen. What's the actual strategy?
It's 3 distinct steps.
Yeah.
And I'll warn you, the third step is emotionally difficult for a lot of people.
Okay, lay it on me. Step 1.
Step 1, summarize decisions. When you reach a milestone in your project, say, you finally fixed that Python code and it works, don't just keep typing. Stop. Ask the AI to generate a full summary of what's been achieved and the current status.
So you're freezing the state of the project in text.
Exactly. Get it out of the fuzzy history and into a clear block of text.
Mm-hmm.
Step 2, restate constraints. Take that summary and manually add back in your non-negotiables. We're using Python. We are targeting this audience. Do not use these libraries.
Because those instructions were probably at the start of the chat, and they've likely fallen off the conveyor belt by now.
They're gone. You are bringing them back from the dead. You are consolidating all the signal.
Mm-hmm.
And now, step 3, restart clean.
Restart, you mean?
I mean, close the window, open a brand new chat, and paste that compressed summary as your very first prompt.
Oh, that hurts. It feels like killing the vibe. I built up all that rapport with the bot, and now I'm just dumping it.
You are. But think about what it does to the architecture.
Hmm.
Think about that U-shaped curve. By restarting, where have you just put your most critical information?
At the beginning.
Where attention is 95%.
Yeah.
And because it's a new prompt, it's also at the end, where attention is 92%. You've completely removed the lost in the middle danger zone.
You've reset the power curve.
You are basically decluttering its desk for it.
I'm manually doing garbage collection. I'm removing the noise, the coffee talk, the failed code attempts, all the drift. You're giving the AI a pure high signal state.
Exactly. And that saves you from the hallucinations.
Because it doesn't have to guess anymore.
It doesn't have to search through a muddy history of 5,000 words to find the right variable name. It's right there at the top. It transforms the AI from a confused, overloaded assistant into a fresh, focused expert.
Who knows exactly what the status is?
Correct. The source frames this as moving from fighting the system to collaborating with it. If you fight the architecture, if you just keep scrolling down and adding more noise accuracy drops, frustration rises.
And my blood pressure spikes.
But if you accept the constraints, if you accept the context window is limited and the quadratic wall is real, you can manage the resource. You become the operator.
So what's the final takeaway here? Because this feels like a lot more work for the user.
It is more work, but it's high leverage work. The final thought from the source is actually really empowering. It says, AI doesn't fail silently, it fails predictably.
Predictably.
The failures, the forgetting, the hallucinations, they aren't random. They're mathematical certainties based on token limits and attention spans. And if you understand the architecture, that limitation becomes leverage.
You know, that actually makes me feel a lot better. It's not personal. It's not that the bot hates my coding style.
It's just math.
It's just math. And once you know the math, you can solve the problem. I love that. So the next time you find yourself screaming at your screen because the chatbot forgot the main character's name, don't spiral.
Don't spiral. Summarize, restate, restart.
I'm definitely trying the restart clean method on my next big project, although I might still miss the banter about the weather.
You can always start a separate chat for that.
Good point. Thanks for listening to this deep dive. Hopefully your next AI session is a little less frustrating and a lot more productive. See you next time.